Hey everyone, and welcome back. I am absolutely thrilled to have you here for another explainer. Just a quick note right up front. This explainer is brought to you by Forge College. Now, if you recall from our last Solidity from Zero session, we spent some time mapping out event syntax and declaration. Learning how to actually define the shape of our events. But let's be real. Defining them is only half the battle, right? Today, we're taking all that theory and we're putting it into motion. We are talking about emitting events and reading transaction logs. We're going to take that beautiful event you declared, pull the trigger, and trace that data straight into the blockchain's transaction receipt. Let's get into it.
So, here is our blueprint for today. We'll kick things off by moving from declaration to action. Then we'll look at the emit keyword, peek inside the transaction receipt, compare topics versus data, and finally wrap up with parsing and gas trade-offs.
All right, part one, from declaration to action.
Think of declaring an event like installing a massive state-of-the-art PA system in a giant building. You're running all the wires, you're hanging the speakers. Basically, you're setting the blueprint and the capability. It's absolutely crucial work, but it's completely silent. Event emission, on the other hand, is actually stepping up to that microphone, hitting the button, and speaking into it so everyone can hear you. It is the exact moment where we take concrete, real-time values, like a user's address or a very specific item ID, and literally write them onto the blockchain as data inside a transaction receipt. Without emission, your declaration is just a really expensive silent speaker.
Moving right along to part two, the emit keyword.
And here is the magic word itself, emit. It sounds super dramatic, but it's really just a single, elegant line of code. When your Solidity function runs and hits this exact line, it takes your concrete parameters, so in this case, the message sender, who's creating the item ID, and a text description, and it just fires them off. It acts as this perfect interface translating your high-level Solidity variables directly into the low-level log entries of the Ethereum virtual machine. This is it. This is the exact moment your smart contract finally speaks to the outside world.
Which brings us to part three, inside the transaction receipt.
Okay, so once we've actually spoken into the microphone, where does that output go? It ends up in a transaction receipt. You could think of it kind of like a highly detailed grocery receipt, or maybe a technical schematic that records exactly what just happened. When you look at a raw transaction log, you're going to see an array called topics and a field called data. Now, at topic 0, the blockchain always stores a hash of the event's signature. That's basically the ID tag for the event type. Then, if we decided to index the creator's address, well, that goes right into topics 1. If we index the item ID, that sits perfectly at topics 2. But what about that description string we emitted earlier? Well, that drops down into the data field, neatly ABI encoded. It's incredibly structured, completely deterministic, and perfectly organized.
I want to pause on that first topic for a second, because it's so important. The event signature hash is the Ketchak256 hash of the event name and its parenthesized parameter types with literally 0 spaces. So for our example, it's item created, open parentheses, address, uint256, string, close parenthesis. And I've got to warn you here, even a minor typo, an accidental spacebar tap, or mixing up a type-off chain will completely mutate this hash. If that happens, your front-end application will just stare blankly at the receipt and ignore the event completely. Precision here is absolutely non-negotiable.
All right, part four, topics versus data.
So there is a very strict architectural divide going on here. Indexed parameters, which become our topics, are highly searchable. Off-chain indexers absolutely love them. But you are strictly limited to a maximum of 3 indexed parameters per event. No exceptions. The blockchain stores them in rigid 32-byte left-padded slots. On the flip side, your non-indexed parameters get bundled together into what we call the data blob. You can stuff as much in there as you want. It's technically unlimited, but the catch is it's completely unsearchable. You can't just ask the blockchain to quickly find an event based on a non-indexed description. You'd literally have to download all the events and check the data blobs yourself. So the rule of thumb, you index for searchability and you use the data blob for heavy context.
Okay, let's look at how you'd actually prove this works in a local development environment, say with the Hardhat script. The workflow is actually elegantly simple. First up, you deploy your contract. Second, you execute a transaction that calls your function to emit the event. And finally, you take the receipt from that transaction and you parse the log.
And this little line is exactly how you parse it. When you pull that receipt, the log is honestly just a bunch of raw, completely unreadable hexadecimal data. But by using a library like ethers.js, you can use the parse log function. Think of ethers as your trusty decoder ring. You hand it the raw hex data along with your event's blueprint, and boom, it instantly translates it back into the original readable arguments. You'll see your message sender address, the integer for your item ID, and that plain text description exactly as you originally emitted them.
And finally, Part 5, Parsing and Gas Tradeoffs.
Let's talk about the one thing that keeps every Web3 developer up at night, right? Gas. Doing nothing obviously costs the least. Writing data to persistent on-chain state storage, like saving variables directly in your contract, is astronomically expensive. Emitting events sits right there in the sweet spot in the middle. It's a fantastic economical alternative to storing data on-chain. But make no mistake, the blockchain still charges you a toll for the privilege of writing to those logs. They aren't free. So please don't just emit a log every time a user clicks a button without having a solid strategy behind it.
Let's quickly summarize the golden rules we've unpacked today. First, there is a wonderfully stable deterministic mapping from your Solidity code straight to the transaction logs. Second, topic 0 is always your signature hash. Seriously, guard it with your life against typos. Third, reserve your index topics purely for the parameters you actually need to search and filter off-chain. And lastly, and maybe most importantly, never forget that events are an off-chain signaling mechanism. They are a megaphone for front-ends to listen to. They are absolutely not a database for other smart contracts to read. If another smart contract needs to verify a value, it has to be stored in a state variable, which is the canonical on-chain truth.
So I want to leave you with this provocative thought as you go off and design your Web3 APIs. Are you indexing the right parameters for your off-chain architecture? Because I promise you, choosing your 3 index topics wisely will absolutely make or break the speed of your front-end applications. And that wraps up our explainer on emitting events and transaction logs. I highly encourage you to visit the website forge.college to learn more about this subject, dive deeper into API design, and master a ton of other fantastic Web3-related topics. Keep practicing, keep emitting those events, and I will see you in the next one.